Cooking mode on.
Meet Jarvis, my own voice control assistant that uses Edge AI voice detection to control and integrate into my home IoT system. Hi, I am Aditya Agarwal and this is Jarvis, and this is my entry into CircuitDigest's Edge AI and IoT challenge. Let's see Jarvis's startup sequence. Once it's initialized, it will try to connect to my Wi-Fi, and with Wi-Fi, it tries to connect it to my home assistant, which is hosted on my Raspberry Pi 5. Once it's connected, it will show us a status LED that it's working now. When it detects motion, it starts recognizing sound. After 6 seconds of inactivity, the light turns off and Jarvis stops listening. So let's try a command. Cooking mode on. When it detects a command, the status LED blinks. And after 6 seconds, LED and Jarvis dies down again. Usually after office, I like to get into my workshop and start building something and start my nightlife just like Batman. So here's our next demo. Alfred Batcave on. Now that started our light, our AC and our projector. This is our Cyped Maixduino AI plus IoT development board provided to me by DigiKey. I've opened the pinout diagram for my board on the laptop for easy reference. Along this, I've also opened up my GitHub, which has hosted my code for Jarvis. I have already pre-made my PIR sensor enclave. It has a PIR sensor and 4 LEDs connected to a 220 ohm resistor. Each of these LEDs are then connected to different GPIOs, and similarly the PIR sensor is also connected to a GPIO. I've used the PIR sensor to detect motion and cause Jarvis to get activated. I did not want the board to be listening for sound recognition all the time because that might cause accidental triggers. The board supports LVGL and a display, so I wanted to add a dashboard to it, but that was not possible. So I have used LEDs as an output here. Now to wire it up, let's find out the pinout for our PIR sensor. Looking at the pinout diagram, I've connected the ground, the VCC, which is the 3.3 volts, and output pin to my Maixduino board. Once the PIR sensor was connected, it's time to connect all the 4 LEDs. For that, we bring out the glue gun. Here, instead of hot gluing everything, I could have soldered the pieces together as well, but hot glue gun works pretty fine for this case, and it's easier to take off as well. After gluing things together, I test out the whole thing using a 12-volt barrel plug power supply, and then I start to assemble the case. Once it's inside the case, I test it out again. Once that test case is also passed, I hot glue in the lid as well. If you're following along the project, I would recommend that you assemble the case first before creating the voice model for Jarvis, because the acoustics changes when we assemble the case and we need to recreate the whole voice model. Now that we know how to assemble our whole project, let's look at how I created the 3D models and files for Jarvis and then 3D printed them. So these were a few iterations that I had created to get to this final design, which incorporated the PIR sensor as well and had holes for the mic as well. Now to create the voice model, open up my GitHub and into the library for speech recognition and the example of get voice model. This example will help you create the voice model, and the final voice model will come out in this format into the serial monitor. I've used CoolTerms to copy the serial monitor output, and I've created a Python file that takes in all these text file for each voice model and creates the final voice model. I suggest going through my GitHub for better documentation. Okay, this is my board, and I need a way to reset it so that I can re-record my voice models and connect it to my laptop. So let's take this board and make some adjustments to it. Now let's make some adjustments to this. To extend the reset button, we just need to find the reset pin on the board and short it with ground. So we connect two wires to both of them and close the whole thing. An accurate voice model is a must not to trigger accidental fires. So I took my time and re-recorded the voice model in the final resting state of Jarvis. I've made some key changes into the main Maixduino speech recognition library. The library had an option to store 4 voice models per command and total of 10 commands. I've bumped it up to 6 voice models per command and total of 14 commands for a more accurate representation and more commands in total. For speech recognition, each of these models gave an error distance, and the lowest error distance was the recognized command. To increase the accuracy to the same number of voice models, I've also added an averaging algorithm to it. Adding a maximum error threshold also curbed my accidental misfires. And one final and most important change that I did was to add a timeout in the speech recognition library. This way, if no voice is recognized for 6 seconds, it times out and resets instead of trying to recognize audio for eternity. All the files, including detailed steps to follow along, can be found on my GitHub. Surrounding Jarvis are these 2 addressable RGB LED strips that are connected to my ESP8266, which is powered using a 5 volts 5 ampere power supply. Jarvis sends its signal to our home assistant through MQTT, and our home assistant is the broker here, which delegates the tasks and sends that task to our ESP8266. Now for our final demo. Good night, Jarvis.